In the first example, it says classify each of the following as linear, quadratic, or exponential. So looking at part A, we have y equals 5x minus 4. The highest exponent is actually 1 in here. It's implied. It's the exponent on the x. So since the highest exponent is 1, this is linear. In part B, we have y equals 3 minus 2 to the exponent x. Since the exponent here is a variable, this is exponential. In part C, we have y equals 1/4 to the exponent x. So again, because the exponent is a variable, this is exponential. And then in part D, we have y equals 6x squared plus 4x. So the highest exponent is 2, making this quadratic. Example 2, it says classify each of the following as linear, quadratic, or exponential again, but this time we have a table of values. So if we have a table of values, we have to calculate the first differences by subtracting the y values. So I'm going to create an extra column and label it FD. And then I'm going to subtract -5 from -1. And that's like adding 5. So we get an answer of 4. Then we have 11 minus -1, just like adding 1 to 11, which gives us 12. Then 31 minus 11 gives us 20. And then 59 minus 31, which gives us 28. So looking at the first differences, I know this table doesn't represent a linear relation because the first differences are not all the same. Now we just have to check what pattern is occurring. Are we adding the same number as we go from one row to the next, or are we multiplying by the same number each time? So if I go from 4 to 12, I'm adding 8. If I take 12 and add 8, I get 20. If I take 20 and add 8, I get 28. So in this case, it's following an addition pattern. Therefore, this is going to be quadratic. Okay, on the back, here's another table. I'm going to, again, add another column and calculate the first differences here. So 4 take away 1, that's 3. 16 take away 1 is 12. And 64 minus 16, that's 48. And 256 minus 64, that's 192. So it's not linear because these are all different. If I was to add a number to get the next number in the pattern, I would be adding 9 because 3 plus 9 is 12. But then when I look, 12 plus 9 doesn't equal to 48. So it can't be an addition pattern that's happening here. Let's check if there's a multiplication pattern. If I'm going from 3 to 12, I'm multiplying by 4. And 12 times 4 gives me 48. And 48 times 4 gives me 192. So this is following multiplication pattern. Therefore, this is exponential. And here's the last example. Again, calculating the first differences. By subtracting the y values, I get 5, 5, 5, and 5. All the first differences are the same. Therefore, this is linear.